So today we're going to divide by polynomials. Okay, or actually we're going to divide polynomials. So we're going to divide both the top and the bottom. And so what we're going to do is we're going to break this section into 2 days. Okay, today we're going to do long division. Tomorrow we're going to do something known as synthetic division. Okay, and then on Thursday you'll probably have a short quiz over the first 2 sections and probably have a worksheet. So let's go ahead and look at this. It says simplify. Now, when we simplify polynomials, in this case we are dividing, we are going to divide each term by 3xy. So I'm going to divide that term by 3xy, that term by 3xy, and this term by 3xy. And so what we could do, and I'm just going to do this so that you can visualize what in fact you do, I'm going to write these individually so that you can see how things are done. Okay, so notice I'm taking each term and I'm dividing those individually by 3xy. Now I know that's kind of a longer step to write out, but if you do it, I think it's a little easier to see what you do. Because what I'm going to do now is I've got, first of all, we're going to deal with coefficients like we did yesterday, the 6 and the 3. Can you cancel anything out? 3 goes into 3 once. 3 goes into 6 how many times? 2. Okay, so far I have 2. Okay. Now let's look at our x's. I have x to the 4th over x. What do I got? X to the 3rd. Good. Next, let's go to the y's. Y cubed over y. What do you have? Y squared. So that one's done. Now what I'm going to do is do the same thing, except for I'm going to now deal with my middle term. So 12 divided by 3 is what? 4. Let's go ahead and start with our x cubed and x. X squared. Y squared over y is y. Okay. Now, on our last one, what do I have? -6. Yep. -6. Okay, let's go ahead and look. Now I have an x, and then that's it, because your y's cancel. And so then that is your final answer. But the biggest thing you need to understand is that each term has to be divided by the 3xy. You can't just divide the first one, which is what a lot of people like to do. So now this one is the same problem that we just got done looking at. It's just written a different way. It's the exact same type of problem we looked at, except for it's written a different way. Now, in this problem, we are dividing by 4CDF. So really, this is written as 20 c to the 4th d squared f minus 16 cdf squared plus 4 cdf. And I am dividing it by 4 cdf. So what I'm going to do is break this down individually, and we're going to look at these individually as 2 separate problems, or 3 separate problems. So I've got 20 c to the 4th d squared f divided by 4 cdf minus 16 cdf squared divided by 4 cdf plus 4 cdf divided by 4 cdf. So we kind of had our warm-up one. So can somebody tell me, what am I going to get from the first term? 5c cubed d. Very good. Minus 4f. Yes? Plus 1. Very good. You understood that the last one is in fact 1. It doesn't just disappear when everything cancels out. Okay, not too bad. Now there's still yet another way that your book's going to write this problem. Do you see what they've done? They've put it to the -1 power. And what to the -1 power, remember, means is in the denominator. So really when you see that -1 right here, what that means is that I can put that over 3xy, and then that's gone. So really that's my problem. So I've got 18x squared y divided by 3xy plus 27x cubed y squared z divided by 3xy. So what do we think we're going to get? From my first division? 6x, very good, plus
9x squared y z.
Yep, perfect. There you go. So not too bad? Think you can handle those? Okay. All right, so then the last type of problems we're going to look at are long division. Now, there's no easy way about this. I mean, there's just one way we can use long division here. And you're going to use up some paper. Sorry. I'll let you go ahead and get that down, and then we'll talk about how to solve this. Now some of you are probably wondering why on earth would you use long division. There are actually times in the advanced math when we do use long division. And I never understood that until I taught those classes, but I was like, oh, that's where you use long division. Same thing with what we're going to do tomorrow. And so first of all, with long division, I'm going to start, if you remember, with my division symbol. Okay? And inside my division symbol, so on the inside, what do you think is going to go there? Yep. Good. X squared plus 3x minus 40. Now my divisor is going to be x minus 5. Now we're going to kind of get a system going here. So it's one of those, if you pay attention early on, you'll get into the system and things should work okay. Very first, you always have to have your highest power. That has to be written first. So you can't write this -5 plus x. Needs to be written x minus 5. Same thing here, inside the division symbol, has to be written in descending order. You have to start with your highest power, next highest power, and then your number. So I'm going to first of all look at x, okay? And I'm going to think, how many times does x go into x squared? Or, think of it this way, x times what will give me x squared? X, right? So now what I'm going to do, if you remember when you did long division, I'm going to take this x and I'm going to multiply it by both the x and the -5. Okay? So what is x times x? X squared. What is x times -5? -5x. And look at how that lines up. Now if you've done things correctly, okay, you're going to have the same term first. So now, when you did long division, when you did it with your numbers, what would you do? What was your next step? You subtract. So this is what I always call the step switch, switch. Instead of subtracting, you know I don't like subtracting. I like to change the signs. So I'm going to switch this sign, and I'm going to switch this sign. And basically, then I've taken care of the subtraction. Now, if I add x squared and -x squared, I get 0. If I add 3x and 5x, I get 8x. Then, what do? Bring down the -40. Very good. Now what we're going to do is we're going to do this the exact same way I started with. Okay? I'm going to see how many times does x go into 8x? Or what times x will give me 8x? 8. So, I'm going to put the number up here. And then what am I going to do? I'm going to take 8 times x, and I get 8x. I'm going to take 8 times -5, and I get -40. What step do I do now? Switch the signs, which is the subtraction step. So I have 8x minus 8x, which is 0. -40 plus 40, which is 0. And so this one actually has no remainder. And my answer is x plus 8. All right, let's look at another one. Okay, x squared plus 7x minus 30 divided by x minus 3. So inside the division symbol, x squared plus 7x minus 30. Outside will be my x minus 3. First step, x times what gives me x squared? X. So now I'm going to take x times each of the terms. So x times x is x squared. X times negative 3 is negative 3x. What do I do now? Switch the sign. So switch, switch. What am I left with? 10x minus 30. Very good. So now I see how many times, or what times x gives me 10x? 10. So I'm going to put plus 10. Now what we do is multiply those. And what do I end up getting? 10x. Very good. Minus 30. Next step is to switch, switch. And you notice that there's nothing left. So your answer is x plus 10. Is it that bad? As long as you get the steps down. Okay. All right, I want you to try this one for me. Okay, you try this one for me. X squared minus 13x plus 12 divided by x minus 1. Okay, so what'd you end up with?
Yeah.
I got x minus 12.
Yeah.
Okay, so, and the reason is because you need to use a negative 12x. So x goes into negative 12x, and your thing should have been negative 12 times. Okay, so let's go and look at another one. This is our very last problem today. So then now, this one's a little different. Okay, it's written kind of like that very third one we looked at. And so this is a squared plus 7a minus 11 divided by what? 2 minus a. So inside my division symbol is going to be a squared plus 7a minus 11. Outside of the division symbol is going to be what? Close. Negative a plus 2. Okay, remember what I said. You always have to have your highest power first. So then now let's go ahead and negative a times what will give me a squared? Negative a. Now for those of you that are struggling and saying, how on earth did they do it? Another way you could do this. Take a squared divided by negative a. That's another way you could do that. A squared divided by negative a is negative a. So when I multiply that out, I get negative a times negative a, which is a squared. I get negative a times 2. What is negative a times 2? Negative 2a. What step do I do now? I switch the signs. And so when I do that, my a squareds cancel. I'm left with 7a plus 2a, which is 9a. I'm going to bring down my 11. So then now, negative a times what gives me 9a? Negative 9. Very good. So negative 9 times negative a is 9a. Negative 9 times 2 is negative 18. Oh, So then now, I switch my signs, and what do you get? 7. This one doesn't come out even. Okay, so what do we call 7? Do you remember? The remainder. And so back when you were in elementary school, you probably did this, R7, right? Okay, yeah, we don't do that in the high school. Okay, what we're going to do is we're going to actually properly write a remainder. And this is very easy. All I'm going to do is do a plus sign. And I'm going to put the 7, but the 7 is divided by negative a plus 2. So whatever remainder you get, all you're going to do is put it over the divisor. That is the proper way to write a remainder. So whatever number here divided by this will be your remainder, and that is going to be your final answer. Now you have 10 problems. These problems will actually be due Friday. Okay, so for those of you that have activities tonight, I would like that you would get it started so that tomorrow goes a little easier, and you will have a quiz Thursday. Okay, but these will be due Friday when I get back. So your assignment, page 315, 12 through 30, the evens.